I would like to make a short video about the use of Vernier Graphical Analysis and how we can just substitute Microsoft Excel in this case when we want to get a graph, for example, that relates to variables. So instead of using Microsoft Excel, we could use this Vernier Graphical Analysis. So you can just scroll down to get a free option here. So you can get the Graphical Analysis app uh, that doesn't need installation and it's going to be running in Chrome browser. So when you click on it, now you will select manual entry, and then let's say that we're gonna have a graph of force versus acceleration. Okay, so I can rename the data set. So I can just call this instead of data set 1, I will say force versus acceleration. And now let's say that here the x-axis will be the force. So it would be force in newtons, and then in my other axis I have the acceleration in meters per second square. Of course, these meters per second square will be in the units. Now suppose that I have a mass of 1 kilogram, but I am doing an experiment, so we get some dispersion in the values. So when the force is 1 newtons, I will have an acceleration of 1 meter per second square. When the force is 2 newtons, I will get an acceleration that is 2.2 meters per second square. When the force is 3 newtons, I will have an acceleration that I will measure that is 2.95 meters per second square. Let's say that when the force is 4 newtons, then I have 4.1 meters per second square. And when the force is 5 newtons, let's say that I have 5.3 meters per second square of acceleration. So this is my data. When I update the name of the column, the labels of the graph were also updated. So now in the x-axis I have the force, in the y-axis I have the acceleration. Now remember that what I want to do is just to obtain a graph of force versus acceleration, and I want just to, in this case, get the equation, the trend line and the equation. So you can go here and you click on this icon and then you say apply curve fit, and then it gives you some options. So you have, for example, the linear, that in this case will be the best option probably. You have the quadratic, you have the power, you have the inverse, you have the inverse square, you have the natural exponent, which is the exponential, you have the natural logarithm, you have a logarithmic function, you have sine, cosine. So you have multiple options. Okay, when you have an exponential problem, which is very common, you will use natural exponent. But in this case, my variables really, in the equation, in the second Newton's law, that say that acceleration is equal to the force divided by the mass, right? If the force is independent variable and the acceleration is a dependent variable, the relation between they both must be linear, and the slope will be the reciprocal of the mass, right? So I would like to get the linear graph, and then I will say applied, and when I say apply, look at this. It gives me the equation of the line, and it say that the slope is 1.05, and we have a y-intercept at minus 0.04, right? So in this case, what really matters is the value of the slope, because we know that the slope is the reciprocal of the mass. So I can just find the mass as 1 over the slope experimentally. Suppose that we're working, in an experiment. And then by finding the reciprocal of the slope, I find the mass of the body. Uh, it's going to be, in this case, 1 over 1.05. So it would be approximately 1. That was, what I was assuming at the beginning of the video, that I had a mass of 1 kilogram. Of course, Vernier Graphical Analysis have a lot of other options. I encourage you to explore the other options that are just given in this app. Uh, And yes, in sometimes could be a good alternative to Microsoft Excel. Thank you for the attention, and I see you in a future video.